Assalamualaikum and hello to the panel. My name is Hasya Afiqah Binti Ahmad Jahid with metric number EN190095 from BNE program. Today, I'd like to propose for all of you my title proposal is optimization of heating pad using electrical heating element for transportation application Flexitank. In this chapter 1, introduction of this project commonly utilized by Flexitank container to transport liquids to their final destination and evenly used to reheat the cargo item before its unloading. Heating pad also designed to allow liquids with a low melting point to solidify easily when exposed to low temperatures. The electric heating pad is thus identified as a new solution for heating pads fit beneath a Flexitank. The purpose of the electric heating pad is to swiftly reheat liquid in the cargo before discharging it at a designated spot. For this project, a plug 13A is used to connect the heating pad to the power source. When power is supplied appropriately to this item, the thermal pressure in the heating pad will increase and an electric heating element will be used to reduce the time required for the liquid in the cargo to return to its original form before being shipped to the customer factory. When the electric heating pad is turned on, a K-type temperature sensor, a K-type thermocouple sensor is used to get the accurately liquid temperature composition temperature measurement. The heating pad is turned on, the NOT MCU. After the electric heating pad is turned on, the ESP8266 NOT MCU will connect to the Blink IoT via Wi-Fi to manage the temperature using Blink app. As a result, when the liquid reach at their final destination, the employers don't have to wait until 3 days for the item to be returned to their original state. The problem statement for this project is the market heating pad. It is called steam heating pad owing to usage of water vapor at the point of release. Next, to develop a heating pad that allows for liquid dilution in transportation while on the way to the delivery location. The project purpose is to combine online control and temperature monitoring in a Blink IoT application using an ESP8266 NOT MCU Wi-Fi model and a K-type thermocouple sensor. The aim is to develop a heating pad that allows for liquid dilution in transportation while on the way to the delivery location. The objectives of this project are to investigate various designs of heating pad used in the market, to develop a transformation heating pad using electrical heating element, to verify the functionality of the developed prototype to confirm the effectiveness of system. The scopes of this project are: first, this project is focusing on the task to speed up the melting time of liquids. Project will be used water as a testing element for unloading cargo. Second, temperature sensors are used to measure the level of heat generated by heating pad. Third, very small heat, so the element will be tested to obtain the best option for heating pad development. Fourth, the Blink app is used as controller to control the liquid temperature using a laptop or handphone. 5, there is 2 heating elements that used to measure heat temperature of electric heating pad. It is K-type thermocouple sensor and the thermometer sensor. 6, there are 7 various types of electric heating pad that been tested for this project. In this chapter 2, I will explain about the functionality of 5 components that I use for my project. First, electric heating pad. For this project, a variety of electric heating pads with various data specification will be used. Cotton, metal, and silicone material are among them. Silicone heating pad material, on the other hand, is frequently utilized and will continue to be used. Silicone warmers are not only lightweight but also flexible, making them easy to store for future use. Silicone also have weight a little over 2.5 grams per cubic centimeter on average. In addition, silicone heaters are made with engraved foil or a wiring system that can quickly heat up to 350 degrees Celsius. Second component is K-type thermocouple sensor. The K-type thermocouple sensor is made up of two conductors that are linked at their ends to produce a junction that allows multiple measurement range to be arranged. When heat is applied to this junction, it produces a voltage that is proportionate to the temperature input. It can also be loaded with the amount of space available in the project to monitor the temperature of the product in the cargo. Third, ESP8266 not MCU. This component module is a self-contained SoC with an embedded TCP IP protocol setup that can provide access to any Wi-Fi network to any microcontroller. It's programmed with 80 instruction set firmware, allowing access it to the Arduino device and gain the same level of Wi-Fi functionality as the Wi-Fi shield. For Blink application, Blink is a new platform that lets you easily create interfaces for managing and monitoring your hardware projects from your iOS or Android mobile. Blink now supports the majority of Arduino boards, Raspberry Pi models, the Node MCU ESP32, ESP32, Critical Core, and other mainstream microcontroller and single board computers. Fifth will be the last component I use for my project, Arduino IDE software. The Arduino IDE development environment includes a text editor for writing code, a message area, a text console, a toolbar with buttons for basic function, and a menu system. It connects to Arduino hardware in order to output and communicate with program. In this chapter 3, the process of completing the analysis of electric heating pad distribution would have many methods to ensure that the project will work well. It is flowchart, block diagram data specification for various electric heating pad, and temperature measurement method for future use. My project block diagram will use a plug 13A or a solar panel as power supply to turn on an electric heating element. When the electric heating pad is turned on, the purchaser will display each liquid reading in the heating pad, which will be monitored by the Blink app that connect through Wi-Fi to the ESP8266 node MCU and get data from K-type thermocouple sensor. This data of the various type of electric heating pad would be tested to know the best electric heating pad for my project shown in the slide. Next, for the final method, the block diagram for temperature measurement. For future use, shown the flow at the slide is controlled by Blink app. To display temperature data room ESP8266 node MCU that get data from K-type of thermocouple sensor. The thermometer sensor would display the data that is always up to date to know the temperature when with more certainty. This is to ensure an accurate temperature estimate. For the rest two testing functionality had been done. It is electric heating pad by using thermometer sensor and testing ESP8266 node MCU using Arduino IDE software. First, electric heating pad by using thermometer sensor. The testing of heating pad A, the data that shown in table 4, in the slides of this testing were taken using a thermometer sensor. The voltage V, current I, and power P for the heating pad A are using 5 volt 2A and 10 watt respectively. As a result, we can determine when the heating pad begins to heat up and when it cools down. It is also worth noting that the heating pad initial temperature is 34.4 degrees Celsius with a maximum temperature of 54.4 degrees Celsius, resulting in an increase in the graph. The graph shown on this slide the various parts of the result electric heat effect by using thermometer sensor. The temperature rises rapidly from 0 to 30 seconds on graph of parts at various temperature. Part 8 of the graph before becoming linear at a mode value of 35 degrees Celsius. The temperature is shown in part B as a linear graph that rises gradually over the course of 30 to 300 seconds before changing to a horizontal graph in a part C. Part C demonstrates that after 300 seconds and beyond, the temperature has begun to stabilize. Second testing ESP8266.MCU testing using Arduino IDE. The ESP9266.MCU is put into the basic configuration. Testing was carried out using the coding shown in the slide, which was developed using the Arduino IDE software by turning on the LED using the Arduino coding. In this chapter 5, the project conclusion is to propose a new heating pad for Flexitank that uses an electric element to help reduce the time it takes for liquid in the container to return to its former state. This project compares the method to the steam heating pad in terms of time that usually company use it. The simulation will begin and data will be collected for the further project in order to compare the results and come to a conclusion for the best material in PSM2. That's all from me. Thank you.